Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 969. Please turn to it. Page 969, and today is our lesson number 144. Problem number 14 is what we're going to do. 14, 15, 16 and 17. Those four problems on a scale of 1 through 20. These are towards the last one-third of the section. They're a little bit challenging. How many integers greater than 20? So we're looking for an integer, and we are told that it has to be more than 20 and less than 30. We're looking for an integer between 20 and 30. How many integers are there that are each product of exactly two different numbers, both of which are prime numbers. Product of exactly two different prime numbers. That's what they're looking for. We're looking for numbers that happen to be product of two different prime numbers that fall between 20 and 30. The easiest and the simplest way to take care of this thing is simply to list all the numbers that fall between 20 and 30 and just go one by one. That way we don't miss anything. So let's do that. It cannot be 20, it has to be more than 20. So 21, 22, 23, 24, 25. 26, 27, 28, 29, and that's it. It cannot be 30. 21 can be written as 7 times 3. Oh, what do you know? We hit a jackpot right away. 21 can be written as 7 times 3, and 7 is a prime number, and so is 3. So 21 qualifies. 22 can be written as 11 times 2. 11 is a prime number, and so is 2. 2 is a prime number. That's what they want to see in this problem. If you know your prime numbers, 2 is a prime number. 2 is the only even number that qualifies as a prime number, because a prime number is something that can be divided only by itself and 1. And the only number that you can divide 2 by is itself and 1. So therefore, even though 2 is an even number, it is a prime number. It is the only even number that is a prime number. 23 is a prime number itself. 23 is a prime number. So the only way you can write 23 as a product of two different numbers is 23 times 1. Now 23 is a prime number, but 1 is not. 1 is not. 1 is not a prime number. 2 is. So that doesn't work. 24, how can we write 24? We can write 24 as 12 times 2. That's not going to work. They're not prime numbers. We can write them as 6 times 4 or 12 times 1 or 24 times 1. It's not going to work. 25 can be written as 5 times 5. 5 is a prime number, and this 5 is a prime number, hence they use the word two different prime numbers. They're not two different prime numbers. They are prime numbers, 5 and 5, but they have to be two different prime numbers. 25 does not work. 26, let's do 26 up here. Oh, I shouldn't erase all that thing blasted. Damn it. 21, 22, 23, 24, 25. 21 was 7 times 3. 7 is a prime number, 3 is a prime number, 11 is a prime number, 2 is a prime number, 22, 23 times 1. 23 is a prime number, but 1 is not, so that doesn't work. 24 didn't work, 25 didn't work, because 25 is the product of two same prime numbers, 5 and 5. Let's do 26 here. 26 can be written as 13 times 2. Oh, what do you know? 13 is a prime number, and so is 2. So 26 happens to be product of two different prime numbers. 27, how can we write 27? We can write 27 as 1 times 27. Neither of them is a prime number. We can write that as 9 times 3. 9 is not a prime number, 3 is. 9 times 3, we can write it like this. But that's only, this is a prime number, this is not. 27 is not going to work. 28 is not going to work. 28 can be written as 14 times 2 or 28 times 1. it's just not going to work. Or 7 times 4. Oh, I forgot that. We can write that as 7 times 4. 7 is a prime number, but 4 is not. And 29 is a prime number itself. 29 is a prime number itself. Therefore, the only way we can write that as a product of two different numbers is 29 times 1. Again, 29 is a prime number, but 1 is not a prime number. So how many do we have? We have 21, that's 1, 22, that's 2, and 26. The answer is 3. The answer is 3. That's answer choice D. Answer choice D. Let's move on to the next one then. Number 15. Number 15. I think I need to change the marker because this marker is dying. And I have one sitting right here. Hopefully this one will be okay. If not, I'll have to open a new package in the middle of the video. My eyes are wandering because I'm looking for where I put the package in case I need to reach for it. Number 15. Number 15. We are given a triangle. Let's put it on the blackboard. Seven minus x, 7 plus x, and 10. And it's a right angle. Let's see what they're looking for. The picture above is a right angle triangle, as we can see. What's the value of 49 plus x squared? How much is 49 plus x squared? Let's find out, shall we? How are we going to do it? Well, what they want you to do here, there are three concepts that they're testing here. One is this guy here, a minus b. Think of 7 as a, x as a b, and think of this as a plus b. And you will see in a second where I'm going with this thing. The first concept that they're testing here is, do you know how to apply your Pythagorean theorem? Pythagorean theorem tells us that the square of the hypotenuse has to equal the square of this side, which is 7 minus x squared. So it's a minus b squared. And you know how to open this thing. That's what they're looking for. Plus 7 plus x squared, which will be a plus b whole squared. Let's open it up then, shall we? Let's open it up. I shouldn't have put the triangle here because we need the room. So that's it. We are done with the triangle. We don't need it anymore. I'm going to erase it. Let's open it. So that's going to be 7 squared minus 2 times 7 times x plus x squared. That takes care of the first part here. Plus this guy right here, which is again 7 squared plus 2 times 7 times x plus x squared. And that's your a squared plus 2ab plus b squared. That's where that is coming from. Same thing here. A squared minus 2ab plus b squared. That's where that is coming from. First thing we notice is that we have 2 times 7 times x, which is 2 times 7 is 14, 14 times x is 14x, with a negative in front of it. So here we have negative 14x, here we have positive 14x. So they drop out. Then we get 7 squared and a 7 squared. So that is 2 times 7 squared, which is 49. And then here we get x squared and x squared right here. X squared and x squared. There's x squared plus x squared is 2 times x squared, 2x squared, which can be written as like this. 2 times 49. See, 149 is right here. Other 49 is right there. And 2 times x squared. 1 is right here. Right here. The other one is right here. And that equals 100. Let's divide both sides by 2. That 2 drops out and we find our answer. The question was how much is 49 plus x squared? The answer is 49 plus x squared is 50. 100 divided by 2 is 50. That's 50. And that's it. We're done. That's all. Let's go on to the next one. Now before we go on to the next one, I'm going to spend a couple of minutes actually to dig deeper into this thing. Even though it's not required here, it is not necessary here. As far as the question is concerned, as far as the exam is concerned, we are done. The question was how much is 49 plus x squared? The answer is 50. 49 plus x squared. 49 plus x squared equals 50. My question is, are you able to tell me very quickly what would x have to be in order for this to be true? Well, the only way 49 plus x squared will be 50 is if x equals to be either positive 1 or a negative 1. X would have to be either positive 1 or negative 1, because in either case, negative 1 squared or positive 1 squared is 1, and 1 plus 49 is 50. Are you able to see now where I'm going with this thing? Are you able to recognize the triangle that they're giving us? The triangle that they're giving us looks something like this. 7 minus x and 7 plus x. If x happens to be positive 1, we'll end up with 7 minus 1 and 7 plus 1, which will be 6 and 8. 6 and 8, and this is, we are told, is 10. Were you able to see right away that this is nothing but a right angle triangle? This is a right angle, not right angle triangle, rather, this is nothing but a 3, 4, 5 triangle incognito. It's a 3, 4, 5 triangle incognito. You see, this 6 can be written as 3 times 2, this 8 can be written as 4 times 2, and this 10 is simply 5 times 2. It's a 3, 4, 5 triangle. Now what happens if x happens to be negative 1? Well, if x happens to be negative 1, nothing is going to happen. It's still the same triangle. This is x minus 1, this is x plus 1. Or rather, is it x minus 1? It's 7 minus 1, isn't it? What does this say? I forget now. 7 minus x. 7 minus x and 7 plus x. Now, if x happens to be negative 1, this will be 7 minus a negative 1 and 7 plus a negative 1. In which case, this will be 8 and this will be 6. This will be 8 and this will be 6. This is still 10. It's still a 3, 4, 5. It's still a 3, 4, 5 triangle. We have just to switch the sides, the 6 and the 8. The two legs have been switched, but it doesn't change anything. It's the same triangle. This is 4 times 2 and this is 3 times 2. And therefore, this is 5 times 2. You see? It's the same triangle. It's just that we pick it up and we flip it. That's all. I don't mean to say flip it, I meant to say rotate it. Flipping is a different connotation. What does incognito mean? Incognito means to be in disguise. To be in disguise. When did we learn this word? I know we learned it, incognito, in our vocabulary lesson, even though it's a very simple word for most native speakers. But contrary to what you may believe, I do not qualify as one. I don't want to shock you, but that is the truth. Incognito. It should be under I. Incognito will begin with an I, not a C. What the hell is the matter with me? Incognito. When did we learn it? I know we learned it. There you go. Day number 42. Just type in vocabulary, day 42, and you will learn this word along with some other interesting and useful word to help you improve your vocabulary for the SAT if you're interested in getting a decent score in the reading part of the exam. Do you understand? We're done with number 15, are we? Let's go on to number 16. Number 16 is a tricky one. Let's first put the graph properly. It goes through this point and that point, and then the maximum happens at this point. I'm going to give this point's name. Let's call this point A and B, where the graph happens to be 0. In other words, that's where the x-intercepts are. Let's see what the problem says. The picture above shows a graph of a quadratic function, and they're calling this function h. They're giving it a name, h. That is just a name. It's just the name of a function. They could have called it f, they could have called it hippo, they could have called it monkey. They choose to call this function h, which is fine. And we are told that its maximum happens when x equals 2, right here. Maximum is when x equals 2, which is same as saying h of 2 is where the maximum is, as we can see right here. In other words, the coordinates of this point, let's call this point C, coordinates of point C are 2 and 0. So far so good. Which of the following could be the value of A? We are told that the value of the function happens to be 0 when x equals, let's actually write it out like I said it. The next thing that we are told is that the value of the function happens to be 0 when x equals a. And that all of that is English language. In mathematics, this is how we will write it. H of a equals 0. That's how we write it in the language of the mathematics. This thing that we just wrote here, h of a equals 0, in English language, this means the value of the function, this function, happens to be 0 when the value of x happens to be a. Our job is to find out what could be the value of a. Let's do it, shall we? Well, what we have to understand here is because of the fact that this function is symmetric along this line. This is called line of symmetry. This line that you see here is called the line of symmetry. Is that something that I put in there, or is this something that they gave? That's not something that they gave, that is something that we inserted. When it happens maximum, we draw a line here, and this is called the line of symmetry. And the reason why it's called line of symmetry is because everything is symmetric on both sides, which implies that whatever the distance is from C to B has to be the same distance as from A to C. Distance from A to C has to be same. A to C has to be same as C to B. And our job is to find out what could be the value of A if the value of the function happens to be 0, which will be either at point B or point A. Let's get going. Let's get going. I'm going to do it on the top. We need the room. Let's begin with E. X equals 4, they tell us. Watch what happens. If x happens to be 4, in which case C to B, as you can see, C to B would be 2. And that would imply that A to C also has to be 2. But A to C cannot be 2, as you can see. Had A to C been 2, it would have gone through 0, because from 0 to 2 is 2. It does not go through 0, clearly. It does not go through that point. It goes through somewhere to the left of the y-axis. E is not the answer, because A to C is not 2. D says 3. D says x equals 3. Well, if x happens to be 3, then that implies that C to B would be 1. C to B would be 1. In which case, the line would have to go, the other part will have to go through this point right here. Because if C to B is 1, then it has to go through this point. This implies that the graph will have to go through 1 and 0, right here, 1 and 0. It clearly does not. The graph goes through somewhere to the left of y-axis. That's not going to work. Let's look at C. C says 2. X equals 2, oh, for crying out loud, this is absurd. X cannot be equal to 2, that's where this is, that's where the maximum is. If that's where the maximum is, then the function cannot have a maximum value and a value of 0 if it's drawn in this way. It cannot have a maximum value and a value of 0 if the value of the maximum is somewhere here, which is not 0, as you can clearly see. The value of the maximum is not 0. That's not going to work. B says 0. X equals to 0. Well, x equals to 0 is right here along the y-axis, when x is equal to 0. When x is equal to 0, this implies that the value of the function is 0. Value of the function when x is 0 is not 0. The value of the function is somewhere here. That doesn't work. The answer is A. The answer is A. A says x equals -1. Let's see what happens here. So now we are no longer dealing with this side here. We are dealing with somewhere here, and we are told that it equals to -1. So let's see what happens. So we have -1 and 0. If it's -1 and 0, then distance from A to C, from -1 to +2, from -1 to +2 equals 3, which means the coordinate of point B, this distance will also have to be 3. This distance is 3, and this distance will also have to be 3, and this is x coordinate of maximum is 2, therefore the coordinates of B are going to be 5 and 2. And there is no problem with that. It is possible. The value of the coordinate, there is no reason why it cannot be 5 and 2. And that's what your graph looks like. The maximum happens at this point right here when x is equal to 2, and its x-intercepts are -1 and 0, and 5 and 0. Why negative 1 and 0? Because negative 1 and 0 there gives us a distance of 3 from the line of symmetry, and this gives a distance of 3 from the line of symmetry. The answer is A. Let's go on to 17, shall we? We're done with this one. Number 17. We are told that H and K are positive. K and H are not positive, rather, they're constant. They're constant. Constants, there are two of them. And we are told that x squared plus kx plus 7 is equivalent to, is same as saying it is equal to, let's put them, should have started out in the middle of the blackboard. X squared plus kx plus 7 is equivalent to x plus 1 times x plus h. And the question simply is, what's the value of k? Well, let's find out, shall we? We're going to do some algebraic manipulation, but it's not that complicated. So let's open the parentheses. That's the first thing to do. X times x is x squared. X times h would be h times x. And this is 1 times x plus 1 times h is just h. I see an x here, we see an x here. We can take out the x common, and we end up with h plus 1. Because again, h times x and h times 1. This is x squared and this is h. And on this side we are told that this quantity equals to x squared plus kx plus 7. What's the very first thing you notice? The very first thing you notice is that this h here, the constant by itself, is what shows up here. Right here, which means h equals 7. H equals 7. What else do we notice? X squared is going to drop out, that plays no role. Another thing that we notice is that our coefficient of x, the coefficient of x is k here, the coefficient of x is h plus 1 here. That tells us that k must equal h plus 1. And h we already know equals 7. So h equals 7, therefore k equals 7 plus 1, which is 8. As they were there looking for value of k. There you go, value of k is 8. The answer is D. And that's all. We're done. Tomorrow we'll do the next page, the last 3 questions in this section, which are going to be a little bit challenging. I'm warning you. Not that these were not, what we just finished were also fairly difficult. They were not easy questions, obviously, but tomorrow is going to get even more hellish. I'll see you tomorrow, okay? Bye now.